So next up we have Professor Maria Liakata. She is a professor in natural language processing in Queen Mary Institute, University of London. I'm so sorry. She also co-leads the NLP and Data Science for mental health interest groups at Alan Turing Institute. Her work has contributed to advances in knowledge discovery from corpora, automation of scientific experimentation and automatic extraction of information from the scientific literature. And she's going to talk about today AdSoLve, addressing socio-technical limitations of LLMs for medical and social computing. So let's go.
Thank you very much. Can everyone hear me well? Great. So yeah, we're very excited. I'm very excited to be here, and we're very excited about this new project. It's a keystone project funded by RAI UK and UKRI on addressing socio-technical limitations of large language models, particularly for medical and social computing. So as I'm sure many of you know, large language models are state-of-the-art algorithms trained on large amounts of textual and multimodal data, and the popular technology, the technology behind very popular systems such as ChatGPT, but also multimodal foundation models. And they have impressive performance in generating human-like text, as well as creative content, multimodal content, translating across languages, answering questions in an informative way. However, they have known technical limitations such as biases, privacy leaks, poor reasoning, lack of explainability. And all of these raise concerns about their use in critical domains such as healthcare and sort of science as well more broadly. So what are we trying to do in this project? So we want to essentially create an extensive evaluation benchmark which includes novel criteria and metrics and tasks for assessing the limitations of large language models in real-world settings, particularly in a medical context, and take a responsible and ethical approach. We also sort of considering and knowing these kind of limitations, we also are working on devising novel mitigating solutions based on new machine learning methodology, but also informed by expertise in healthcare, ethics, and law. So there's sort of, I'll talk a little bit about the use cases, and via co-creation with domain experts. And the kind of methodologies we're working on are development of modules for temporal reasoning. We know these models are really bad at sort of doing longitudinal tasks and sort of understanding the order between different kinds of events. Situational awareness, particularly in long-form text. Dialogue and multimodal data, so alignment with human preferences, particularly in a cross-modal setting, bias reduction, and privacy preservation. So a little bit about the team. So this is quite a large project. There's 12 co-Is, I'm a PI, and from 4 different institutions, Warwick, Sheffield, Queen Mary, which is the lead, and Nottingham. And we have a range of expertise among ourselves. So we have NLP experts, vision experts, people who've been working on responsible research and innovation, social computing, ethics experts, but also experts in psychiatry and law who are kind of the domain experts for the use cases. And we have a range of different multidisciplinary teams and partners involved here, and our partners range from large conglomerates such as Microsoft, Accenture, Bloomberg, Canon Medical, to more specialized companies in healthcare. We have legal companies and NHS trusts, NHS England, research centers, and also standards and regulatory bodies. So importantly, what we're trying to do here as well is make sure that in each part of the project we have people involved from different levels of expertise, so that there aren't kind of siloed work packages with people, for example, in computer science working on a specific, let's say, mitigation methodology without the sort of domain experts being involved. So the project itself, the way it's structured, and I'll go more deeply into kind of current progress, involves 3 main use cases. So we have a use case in multimodal medical diagnostics, where we're particularly interested in multimodal longitudinal monitoring, as well as bringing together sort of the different modalities for diagnosis. We have a use case in AI support for mental health, where, as well as the longitudinal monitoring, what we're looking at is as well as better ways of doing summarization, especially with a better understanding of temporal ordering of events, and also dialogue-based self-management, which at the moment this is not really feasible. And then finally, we have a use case in legal support, which again covers particularly summarization of documents, legal documents, court cases, and dialogue system for legal advice. And then we have these work streams that are cut across these use cases, where we have things like a sort of an overarching work stream where we look at requirements around what experts need in terms of working on the ground with these kinds of systems, and this involves co-creation workshops and a lot of sort of engagement with stakeholders. We have the second overarching work stream, which is around evaluation, which takes this kind of feedback, but also very much sort of is around the operationalization of requirements into large benchmarks and evaluation tasks. And I'll talk a little bit more about this in more detail. And then we have the strictly more technical work streams, which are around improving the temporal reasoning and the situational awareness, but also things like privacy preservation and then finally, sort of the multimodal aspect of diagnostics. And so there is, as I said, a lot of sort of engagement with stakeholders. So I guess the main thing to take out of this is that we're starting from December, which is kind of the launch of the I guess a launch event and the first main workshop with stakeholders. There's going to be these kind of interactive workshops every 3 months. And so if there are people who are interested, you can contact me, because we're still, even though we have a large set of partners, we're still looking at broadening our scope in terms of our stakeholders. So what are we actually doing in this project? So obviously this project started in May, but obviously it also builds up on work that we've already been doing in this direction. So we have been working on new methods for evaluation, particularly based on atomic natural language inference, and hopefully there'll be more time to talk about this, cross-model alignment with preference data, synthetic data evaluation, and we have a paper that I'm going to talk about on synthetic data, as on a synthetic data evaluation benchmark. We're working on synthetic data for privacy preservation, particularly in the NHS, temporally aware summarization in mental health, and I'll talk more about this, modules for temporal reasoning, and looking more broadly at reasoning limitations of LLMs. So we're currently preparing this large survey paper. And then the next steps will be around working with multimodal data sets, and particularly we're going to be working with pancreatic cancer, explainability of large language models, and personalized generation and monitoring for dialogue. So I'll talk a little bit now more, zoom in into some of the work that we've been doing. So in terms of an evaluation framework, we've just had this paper accepted in the Journal of Computational Linguistics on sort of this framework for evaluating synthetic language data. And now, why do we actually care about this? Why is evaluating the quality of language data, of synthetic language data, important? Well, for one, a lot of the current use of large language models such as ChatGPT and a lot of LLMs that people are using will be resulting in a lot of sort of artificially generated data out there. And so actually being able to understand the quality of this data is really important. And particularly, we have had a focus on synthetic language data from individuals, so from social media data. Now, another main interest in this is that the sort of social media platforms increasingly are not wanting to share their data. There isn't enough of good quality annotated data, and often also data cannot be shared. So having a good way of synthetically creating language data about individuals is important. And so what we do in this paper is we generate synthetic data using different strategies. So we use LLMs, but also we use techniques such as diverse paraphrasing, back translation, syntactically guided paraphrasing, differential paraphrasing, and we evaluate this in different ways. So one is through introducing metrics for intrinsic evaluation. Some of them are existing metrics, and then we also introduce some metrics based on natural language inference, and then we also evaluate them in an extrinsic way. So basically there's this whole part which is around the intrinsic criteria, which are particularly looking at meaning preservation, style preservation, and divergence as a proxy for privacy. So you don't want basically your synthetic data to be exactly the same as your original, so you want it to be nicely paraphrased. And then we look at it from an extrinsic point of view, where you basically look at we basically look at tasks that show how useful this data is, and also how privacy preserving. So kind of talking a little bit more about the extrinsic evaluation, we basically have one task which is around looking at privacy preservation, and here the idea is to check whether we can, if we substitute the data, if we substitute original data with synthetic data and train classifiers, how much are we likely to re-identify the original people, who the people who had created the original data. And then in our and the second task is around looking at the usefulness of the synthetic data in terms of improving augmentation, for example. So you can use it instead of the original data, or use parts of the original data and parts of the synthetic data, and see how this affects the performance of downstream class tasks. And the other interesting thing about this is that we have considered tasks that operate at different levels of temporal granularity. And again, if you're interested in this, there's the paper, but also I can talk to you more about it in the break. So then I wanted to talk to you about our hybrid system for clinically meaningful timeline summarization. So this assumes that you have some kind of user-generated content like this, where this is a timeline of posts from social media in this case, where an individual is expressing some kind of thoughts, and you can see that there is an escalation in their thinking, in their mood. So they're increasingly getting more and more upset, and so there's this kind of this sort of assumption that this timeline that you have at hand conveys this information, and we had worked on this in sort of previous publications, and now what we want to do in this work is, this is also a paper from ACL this year, is to see if you can leverage this kind of information that is available in people's posts in social media for actually enhancing, augmenting, I guess, the knowledge that a clinician has about this person. Now, if you have the timeline as it is, it's actually very noisy. You can't really see what's going on with this individual. Yes, there's this kind of burst of emotions, but there's sort of events and things all over the place. So what we want to do here is actually take this noisy timeline and turn it into a clinically meaningful timeline summary, which can capture fluctuations in individuals' state of mind. And this can assist in sort of prevention and monitoring and early detection, and also organize information about a person's diagnosis in a way that is actually meaningful to a clinician. So basically based on aspects that the clinician finds useful. So we have been working closely with clinical psychologists, and they sort of offered a range of kind of different aspects that they were interested in, such as mental states, interpersonal and intrapersonal patterns, and sort of moments of change. And so what we wanted to do is essentially be able to translate this kind of the noisy timeline in something that actually addresses these aspects of sort of the mental state of the individual, their intrapersonal and interpersonal relations, and how basically and the sort of changes in their condition. So the way we've approached this was by having a hybrid system which is based on a hierarchical variational autoencoder to structure an evidence summary. So it's essentially, this is like taking the timeline and creating a sort of compact first-person summary, and then translating that into a high-level summary that actually addresses the aspects that the clinicians are interested in. So what the diagram shows is essentially that you have this kind of way of creating this timeline summarization model that you then translate, and this is based on this kind of structural hierarchical VAE system, and then that timeline summary that results from there is translated via instruction prompts through an LLM into kind of this high-level clinical summary. And I guess I could say a little bit more about the system. So this is kind of the system for the first-person clinically meaningful timeline summarization. So for the evidence summarization part. And I guess the main thing here is how we get the structure, given that this is actually an unsupervised approach, so we didn't have enough summaries to train a system. So what we wanted is to use the VAE to essentially reconstruct parts of the timeline, which we call segments, and are anchored around kind of the points of change that I showed initially in the timeline, and basically this sort of the hierarchical VAE allows this kind of capturing relations between features and between segments, and then we have this the generation part, which sort of conditions these representations. So this is the part to the left, with sort of keywords that respond to kind of important aspects that are defined by clinicians, and sort of 3 or 4 annotated timelines. And again, if you're interested, there's the sort of the reference to this paper. I have, I guess, very little time left for my the other work I wanted to talk about, which is around enhancing transformers so that basically they can become temporally aware. So far there isn't a really good sense of temporality in these systems, and I guess what we've done is, for a range of different tasks where we actually are interested in capturing changes over time, and these can be at a different temporal granularity, so you could have these kind of moments of change in the social media timelines, which is the talk life one, but also you could have kind of more long-range changes, for example, in stance towards a rumor or topic shifts in a conversation. So we want to be able to have a system that captures change as well at different levels of temporal granularity. And essentially the solution we've adopted here is to actually modify the top layers of a transformer so that it can jointly model context and time dynamics. And there's the paper there, which is going to be presented at NLP this year. And finally, yes, I just wanted to remind everyone about where we're going to. So we're still continuing with the work on temporality, which is very important in sort of a lot of the diagnostic tasks, not only in mental health, but also when you have things like X-rays from different kind of points in time. So any kind of longitudinal diagnostics, temporality is important. We're in the process of working with multimodal data sets for pancreatic cancer. We're already working on explainability of LLMs, but not published yet, and personalized generation and monitoring. So, and you can read more about sort of the current papers in this project. Sorry. Thank you.
Thank you so much. We are open for questions if anyone wants to go first. Perfect.
Thank you very much for the talk. Just looking at some of the example timelines there with this sort of very noisy data, I wondered if you ever have a challenge not almost doing a disservice to what the person is saying, and is it ever a challenge to ensure that the LLM is capturing some of the subtleties in the language? Do you have problems with things like irony, or if someone's downplaying what they're saying, or the opposite, where it looks like they're saying a lot but perhaps they're feeling fine?
Yeah, so this is why we're interested in sort of the synthetic language generation, and sort of why, not just for privacy preservation purposes and augmentation purposes, but also for style preservation. And we're finding, for example, at the moment that things like disfluencies are not captured well. I think sarcasm, we haven't specifically tested for sarcasm, but yeah, it's sort of, I think it depends a lot on the context and how much it looks like other training data, whether that's being captured. But it definitely, things like disfluencies, which are important a lot when you're looking at mental health, for example, or a decline in cognition. So we're also doing a lot of work, I didn't mention this, but we're also doing a lot of work with dementia, and there, of course, capturing disfluencies is really important.
Perfect. Yeah.
So just following on from that, synthetic data, I mean, it's always, there are perils. I mean, how do you make sure you're not just learning artifacts from the synthetic generation mechanism and these sorts of things?
So at the moment, we're not training our LLMs on synthetic data and sort of releasing them. So we have been focusing a lot on the evaluation of the synthetic data according to different kinds of aspects. And so I think the kind of the meaning preservation aspect is where we're trying to make sure that this isn't happening. But it is an issue, and I think it's something that we can discuss later at the panel, what this means, this prevalence of synthetic data.
There's one question on Slido for you. It's what sort of collaboration are you open to if someone from the medical field with no AI LLM background would like to venture into? What would you advise?
So in terms of collaborating with the project, yes. So we want to understand how people work on the ground and how they envisage using these models. And we've had so far some conversations with regulatory stakeholders, and we found that the discussion was at a very high level. So what we want to do is sort of zoom in more into the use cases. And in our event in December, we plan to have a show and tell. So we kind of show, what are some things that we're thinking of doing, and then get feedback. So I think that's kind of really having this sort of concrete answers in terms of what the concerns are and what the practice is. And on what they would like to see. I think one of the challenges is that people don't necessarily, they know what they're doing now, but sometimes they can't imagine what they could be doing. And so I think the co-creation has this challenge in sort of trying to have this kind of iteration of show and tell and sort of feedback.
Perfect, thank you. We'll take one more question, yeah. Perfect.
Hi again, thank you for the talk. So you talked about reasoning and you've talked about temporality. One of the underlying issues that I think that a large part of the LLMs have is the coherence of an underlying world model. And I'm wondering whether you're struggling with that as well. So the idea there would be that if you don't have a coherent world model, that then relying on some type of temporal unfolding wouldn't be reasonable, it wouldn't be understood by the LLM.
So there has been work so far to try and address temporality in terms of at least temporal ordering of events. So there's different aspects to the temporality, right? One is understanding kind of the sequence of events in sort of reconstructing a timeline, and the other one is around being able to process the long form aspect of those, and sort of the temporal distance between events and what significance they might have, for example, in a diagnostic task. And so I guess in terms of having like this world model, there's been work that is trying to address even the notions of before and after, sort of getting that right. But a lot of the focus has been on pairs of events and not multi-event narratives. So this is what we're trying to focus on, is sort of bring in sort of this kind of multi-event narrative perspective, where we are sort of leveraging some annotated corpora on narratives for that. But there is also the issue around how we kind of better inject knowledge, real-world knowledge, common sense knowledge into these systems as a sort of components that can augment the reasoning. So there's different directions there for how you improve the temporal reasoning and reasoning overall.
Thank you.
Perfect. Thank you so much, Maria. That was really nice. Thank you.